Talking Trees with Lily and Jad. Welcome to Talking Trees. In today's episode, we explore a comprehensive review of how rising temperatures and heat waves impact city trees. This article delves into the physiological, biochemical, and molecular responses of trees under thermal stress, examining critical processes like photosynthesis, respiration, and water regulation. Join us as we uncover the science behind how our trees adapt and survive in a warming world.
Hey everyone, thanks for joining us for another deep dive. We're all about exploring the latest research and sharing practical insights. And today we're tackling a topic that's becoming increasingly crucial in our field.
Yeah, that's right.
Understanding how rising temperatures and those increasingly frequent heat waves are impacting our urban forests.
As arborists, we're the ones on the front lines making those decisions about which trees to plant, how to protect them, and how to manage these ecosystems in the long term.
It's a huge responsibility, especially when you consider that climate models are predicting even more intense and frequent heat waves in the coming decades.
Right. And one of the key things we need to grasp is the urban heat island effect.
Oh, yeah, absolutely. We're all familiar with the concept, of course.
Right, of course. But it's worth emphasizing just how much hotter cities can get compared to those surrounding rural areas.
All that concrete and asphalt building density, it all traps and radiates heat, creating these little islands of heat.
Exactly. And that means our urban trees are starting at a disadvantage, right? They're facing these higher baseline temperatures than their counterparts out in the forests.
Yeah, it's like they're running a marathon in a sauna.
Haha, I like that analogy. It's a good way to picture it. But of course, trees have their own unique ways of coping with heat, which we'll delve into later.
Right, but in terms of just the baseline temperature they have to deal with, it's significantly higher in those urban environments.
Absolutely. And that's before we even factor in those heat waves.
So thinking practically, how does this impact our work? Say, for instance, we're selecting trees for a new park in a dense urban area.
Well, that's where understanding this urban heat island effect becomes crucial. Take that study from Turin, Italy, for example.
Okay.
They use remote sensing to actually map out the urban heat island, and then they use that data to inform their urban forestry strategies.
So they weren't just planting trees haphazardly, they were being strategic about it.
Exactly. They were maximizing those cooling benefits. And what's interesting is they found that this approach not only helped mitigate the heat island effect, but it actually reduced the energy demand for cooling buildings in those areas.
Wow. So we're not just planting trees, we're actually shaping microclimates.
Precisely. That's the power you have as arborists.
That's amazing. Okay, so we've talked about the urban heat island effect, but what actually happens to trees when they get stressed by heat? I mean, we all see the obvious signs like leaf scorch.
Sure. But it's important to remember that heat stress impacts trees at every level.
Oh, yeah.
From the cellular function to the overall health of the whole tree.
So it's not just what we see on the surface. There's a lot happening beneath the bark.
You got it. We see those visible symptoms, but the internal damage, the things we don't immediately see those, are critical too.
You're talking about things like impaired photosynthesis, increased respiration, and oxidative stress.
Exactly. It's this kind of slow burn that can weaken the tree over time.
And it makes them more susceptible to other problems like pests and diseases.
Absolutely. Remember that heat wave in Europe back in 2003?
Oh, yeah. I remember reading about that. It was devastating.
It actually turned the whole region into a net CO2 source.
A CO2 source? That's terrifying. What happened?
Forest productivity was so badly hit that the trees were actually releasing more CO2 than they were absorbing.
Wow. And that's just from one heat wave. It's a stark reminder of what we're up against.
Right. And it wasn't just mature trees that were affected either. There's been research looking at the impacts of spring heat waves on those emerging leaves.
Those new leaves are so vulnerable. It's like they haven't had time to toughen up yet.
Exactly. There's a study by Filewood and Thomas from 2014. They looked at sugar maples.
Okay.
And they found that even a short spring heat wave could cause significant leaf loss, reduce photosynthesis, and potentially impact the tree's long-term carbon gain.
So even a short burst of intense heat early in the growing season can have lasting consequences.
Absolutely. And that's something we need to be more aware of as arborists. It's not just about surviving the summer heat anymore. We need to be thinking about the whole year.
Right, it's a whole new ballgame with these changing climate patterns.
Exactly.
Those emerging leaves in spring, they're so sensitive, it's a critical growth period. And if those new leaves get damaged by heat, well, it can really set the tree back.
Absolutely. So we need to be extra vigilant during those spring months, making sure those young trees have the resources they need to withstand those early heat waves.
Like we need to give them a good head start.
Exactly. A strong foundation to build on.
Like being a tree coach.
Haha, I like that.
We're here to guide them to success.
That's a great way to think about it. We're in this together. with the trees.
We are. All right, so we've talked about the urban heat island effect and the impacts of heat stress on trees, but now let's dive into some of the strategies we can use to protect our urban forests in these increasingly hot environments.
Sounds good. Let's get practical. And it's not just the heat itself we need to think about. It's the combination of stresses.
Oh yeah, for sure. Heat and drought that often go hand in hand.
Exactly. It's like a 1-2 punch for those trees.
So how does that actually play out physiologically? I mean, inside the tree.
Well, think about photosynthesis for a minute.
Okay.
Correa and their team did some fascinating work with Eucalyptus globulus.
Okay.
That's a species we see a lot in urban landscapes.
Right.
And they found that heat directly damages the photosynthetic machinery within the leaves.
Oh, wow. So the heat is basically messing with the tree's ability to convert sunlight into energy.
Exactly. And then on top of that, you add drought into the mix.
Right?
Which forces those stomata to close up, to conserve water.
Makes sense.
But when those stomata close, it limits the uptake of carbon dioxide.
Ah, so it's like a double whammy. The heat is damaging the system and the drought is cutting off the supply.
You got it. And that's why we see trees really struggle during those combined heat and drought events.
It's like a recipe for disaster.
It can be, and this is where irrigation becomes so important.
Especially in those urban environments where water can be so limited.
Absolutely. Even trees that we generally consider to be drought tolerant, they might need a little extra help during those extreme conditions.
So we can't just rely on natural rainfall. We have to be proactive.
Right. We need to be monitoring soil moisture and making sure those trees are getting the water they need.
Okay, so we've talked about irrigation. Now let's shift gears a bit and talk about assessing heat stress. I mean, we're all experts at identifying those visual signs, the leaf scorch, the wilting.
Right. But the problem is those are often late indicators. By the time we see those symptoms, the damage might already be done.
It's like waiting for the check engine light to come on before taking your car in for service.
Exactly. And that's where physiological tests can really come in handy.
They give us a much earlier and more precise picture.
Exactly.
So you're talking about things like chlorophyll fluorescence, electrolyte leakage, root, growth potential tests.
Exactly.
These aren't exactly everyday tools for most arborists.
Right. But they can be incredibly valuable. Think of it like having X-ray vision for your trees.
I like that.
So, for example, chlorophyll fluorescence measures the efficiency of photosynthesis at the leaf level.
Okay.
So it can detect those subtle changes in photosynthetic activity that we might not be able to see with our naked eye.
So we can actually see how well the tree is converting sunlight into energy.
Exactly. Then you've got electrolyte leakage, which measures damage to cell membranes.
Okay.
So basically, it's like a stress test for the tree's cells.
If those cell membranes are leaking, it means the tree's in trouble.
Right. And then finally, we have root growth potential tests, which are particularly useful for young trees. Strong root growth is essential for water and nutrient uptake.
Especially during those times of stress.
Exactly. So instead of waiting for those visual cues, which can be lagging indicators, we can use these physiological tests to get a real-time assessment of how the tree is coping.
It's like preventative medicine for trees.
I love that analogy. It's a great way to think about it.
Okay, so we have all these tools to assess heat stress. But even with all that knowledge, selecting the right trees for these increasingly hot environments, it can still be tricky.
It definitely is. There's no magic bullet. And we can't just assume that a tree from a warmer climate will automatically thrive in a hot urban environment.
Right, there are so many factors at play.
Exactly. I've been hearing a lot about provenance selection lately.
Oh yeah, me too. What's that all about? And how does it relate to heat tolerance?
So provenance selection recognizes that there's genetic variation within a species.
Okay.
So trees from different parts of a species range. They might have different adaptations, even if they look very similar.
So a sugar maple from Alabama might have a different level of heat tolerance than a sugar maple from Minnesota.
Exactly, even though they're both sugar maples.
Interesting. So how do we go about finding those trees that are best suited for our particular urban environments? Are there any resources we can use, like the RHS Plat Finder or those university extension services?
Those are great starting points.
Okay.
But we need to be a bit cautious about relying solely on those general climate tolerances.
Because there might be variation within the species.
Exactly. There are some studies that have shown conflicting results, so we need to be careful about making those broad generalizations.
So we need to do our homework and look for research that specifically focuses on the provenance of the trees we're considering.
Absolutely. For example, there's a study by Rubikowski and their team from 2012. They looked at red maples and northern red oaks from different provenances, and they found significant significant differences in heat tolerance among the trees from those different regions.
Interesting.
And there's also Weston Bowrell's research from 2007 on red maple genotypes from contrasting climates. They found that the trees from those warmer climates actually had higher photosynthetic rates under heat stress.
So there's real evidence to support this idea of provenance selection.
There is, but we definitely need more research on a wider range of species to make those truly informed decisions.
And that's where we as arborists can really make a difference.
Absolutely. Your observations and experiences on the ground are invaluable.
We're the ones out there seeing these trees in action, seeing how they perform in different conditions.
Exactly. So let's move on to some practical strategies for protecting trees from heat stress once they're in the ground.
Okay, let's talk solutions. We've covered a lot of the challenges, but I'm sure our listeners are eager to hear about what they can actually do to help their trees thrive.
All right, so let's talk about some of those solutions, some things we can do to help our trees beat the heat.
I think everyone listening is eager to get to this part. We've covered the challenges, but what can we actually do?
Well, the good news is that we do have a range of tactical approaches that we can use. And I think it's safe to say that irrigation has to be our first line of defense, especially when we're dealing with those combined heat and drought situations.
Absolutely. We can't just rely on natural rainfall.
Right. Especially in urban areas where water can be so scarce.
So even trees in irrigated areas might need some supplemental watering during those really intense heat waves.
Exactly. We need to be monitoring soil moisture and adjusting irrigation schedules as needed.
And it's not just the amount of water, but also the timing.
Right. Deeper, infrequent watering is generally better than frequent, shallow watering.
Because it encourages those deeper roots.
Exactly. Those deep roots are so important for drought tolerance.
Okay, so we've got irrigation. What about nutrient management? Can we give our trees a little extra boost to help them handle the heat?
Well, there's definitely research that suggests that certain nutrients can play a role in enhancing heat tolerance.
Okay, like what?
Well, calcium, for example.
Okay.
Calcium is involved in cell wall stability.
Right.
Which is important for maintaining cell integrity under stress.
So it helps prevent those cell membranes from getting leaky.
Exactly. And then you've got silicon, which has been shown to improve drought tolerance in some plants.
How so?
It enhances water uptake and reduces transpiration.
So it's like a water conservation tool for the tree.
Exactly. And then you have potassium and magnesium.
Right, those are essential nutrients.
They are. They're important for photosynthesis and overall plant health, which can help trees cope with stress in general.
So it sounds like we need to be thinking about a really balanced nutrient program that addresses those specific needs of trees in these heat-stressed environments.
Absolutely. And then there's also a growing interest in the use of biostimulants.
Oh yeah, biostimulants, they're fascinating.
Right. They're substances that can stimulate those natural processes in plants and potentially enhance their stress tolerance.
It's almost like we're trying to train trees to be more resilient.
It is. It's a really cool concept, but the research on trees specifically is still fairly limited.
Okay, what do we know so far?
Well, there are some studies that suggest certain biostimulants can improve drought tolerance and reduce oxidative stress.
Okay, so there's promise.
There is, but we need more research to really understand how they work and how effective they are for different species.
So more field trials, more real-world data.
Exactly. And that's where, citizen science projects and collaborations between researchers and arborists, I think those are going to be key.
Absolutely. We need to work together on this.
We do. Okay, so we've talked about irrigation, we've talked about nutrient management, we've talked about biostimulants. Now there's one more tool we should discuss, and that's chemical enhancement.
Okay, this is where things can get a little bit controversial, right? Using chemicals to actually boost a tree's heat tolerance?
It can be a sensitive topic. There's definitely a need for caution and responsible use.
Right.
But research has shown that certain chemicals, like triazoles,
Okay.
they can induce stress protective compounds in plants.
I know triazoles are found in some fungicides and growth regulators. How do they actually work to enhance heat tolerance?
Well, they essentially trigger the production of antioxidants and other protective molecules within the tree. And that helps to reduce the damage caused by the heat stress.
So it's like giving the tree a temporary shield.
Exactly. It's not a permanent solution, but it can be a really valuable tool in certain situations.
Like protecting newly planted trees during a particular bad heat wave.
Exactly. But it's really important to remember that there are potential drawbacks.
Of course, we have to weigh those risks and benefits.
Absolutely. And we need to make sure that we're using these chemicals judiciously and in accordance with all regulations.
It's all about making those informed decisions.
Exactly.
Based on the best available science and the specific needs of those trees that we're managing.
I think that's a great point to end on. We've covered a lot of ground.
We have, from the urban heat island effect to all the different strategies we can use.
Right. And it's clear that understanding and addressing this whole issue of heat stress It's absolutely vital for the future of our urban forests.
Absolutely. And it's not just a scientific challenge, it's a call to action for all of us.
It is. We need to work together, share our knowledge, and be relentless in our pursuit of solutions.
Our urban forests are depending on us.
They are.
Well, thank you so much for joining us on this deep dive into the world of heat-stressed trees. Keep those trees thriving, and we'll catch you next time on the Deep Dive.
Thank you for joining us on today's episode of Talking Trees. We've journeyed through the complex challenges posed by rising temperatures and heat waves on our urban trees, exploring how thermal stress affects their photosynthesis, respiration, and water balance. We've also uncovered the fascinating biochemical and molecular mechanisms, from osmolyte accumulation to heat shock proteins and volatile organic compounds, that help trees withstand extreme heat. As our cities continue to warm, understanding these processes is key to selecting resilient species and mitigating thermal damage. We hope today's discussion deepens your appreciation for the remarkable adaptability of our urban forests. Until next time, keep nurturing the green that sustains us.